So in this video we're going to look at an example where we differentiate a function that involves the inverse secant function. And this was the formula that was developed for the derivative of the inverse secant function, or arcsecant. So remember, it's either secant inverse or arcsecant, are both ways of saying the inverse secant. So here we have the function g of x equals the secant inverse of x squared, all squared. And the key here is to notice we have function composition going on. In fact, we have three functions involved. We have the x squared function inside of the secant inverse function, and then the secant inverse function is itself inside of a squaring function. So to take the derivative, we're going to need to apply the chain rule 2 times. So I'm going to take the derivative, and I'm not going to do a u substitution in this case. I'm going to go ahead and just walk through how I would do it without doing a u substitution. So g prime of x. So we start with the outermost function, which is the squaring function. We take the derivative of the squaring function. So it's going to be 2 times the stuff inside the squaring function. And then, of course, you reduce that exponent by 1. Which is just going to be raising it to the first power, so we wouldn't actually need to write it. And then by the chain rule, we're going to go times, and then we have to take the inverse of the function that's directly inside of the squaring function, which is the secant inverse. So that's going to be this guy right over here. So we're going to get times 1 over, and it's going to be the absolute value of the stuff inside the secant function, the absolute value of the stuff inside the arcsecant function. So the absolute value of x squared times the square root, and it's going to be the stuff inside the arcsecant function squared. So it's going to be x squared squared, and then minus 1. And then we have to apply the chain rule again, because we just took the derivative of the arcsecant function, but now we have to take the derivative of the function inside that function. So the derivative of x squared is going to be twice x, and then we want to do some simplifying. So in the numerator, we're going to get 2 times 2 is 4, times x is 4x, times the secant inverse. So secant inverse of x squared. So that takes care of the numerator all over. The thing to notice here is we don't actually need the absolute value sign, because if we put a negative number in for x, it will get squared, making it positive. So I can drop the absolute value from that, times the square root, and x squared squared is going to be x to the 4th minus 1. And that's about as simplified as we can make it in this particular case.